Hello and welcome to another coding ASMR video. Today, as you can see on screen, we are doing Leetcode, very famous for being a source for interview questions. In the past, I did some coding challenges of Code Wars. Today we're doing Leetcode, and I am not that familiar with Leetcode, but I think we're just doing the problem number 456, which is today's daily problem. Without further ado, let's get into it. Here's the description. Given an array of n integers nums, that's what we get as input, a 132 pattern is a subsequence of 3 integers nums I, j, and k, such that I smaller than j smaller than k. So we have to find 3 numbers in a row where the third is in between the first 2, basically. Return true if there is a 132 pattern in the array, otherwise return false. Okay, so here they are all increasing, so we can find a number towards the end that's in between 2 of the previous numbers. Here the 2 is in between the 1 and the 4, and here there are actually many, but we only need to say if it's true or not. We don't need to find the sequences. Now I've taken this and I've copy pasted it to VS Code, so we can try around with this here. Alright, let me think for a bit. Alright, so my first thought is that we update a minimum and a maximum. Well, first, we can check the length. So if n is smaller than 3, return false. Otherwise, we have to find 2 numbers that are increasing. So the current minimum will be num0, and then for current value in nums from 1 on, and let's set the current maximum to -1, just so it's already defined. And I might be completely off here, but we'll see. If the current value is bigger than the current minimum, let me spin it around. Current minimum is smaller than the current value, then we can update the max. So curmax. Why are my indents so weird? Current maximum will be current value. Maybe we need to save. I'm just thinking when we update this min and max pairing, because if there's a smaller minimum coming, we might want to use that, but at the same time, what if there is no maximum after that? That will be useful. So we might want to keep all of the pairs and check. This will probably have a long runtime though, but this might be what we need. Well, let's just check this one. If current maximum, then we have found one. And that will be return true. Otherwise, at the end, we just return false. Let's create some test cases. So if that is equal to false, and then also this is an example for true. Let's try these two. Okay, so we can't find that one because we take this and then this and we never update the minimum. Okay, so update the max. This should only be done if we haven't set the current max yet. Otherwise, we only want to do this if the current value is bigger than our current max. And then this will be check for middle value, and we update the min if the current value is smaller. I think this should fix this test case, but I know for a fact this is not yet complete. Oh, I did not consider that there are negative numbers in that, but that's not that bad. Okay, let's also take this test case. Oops. And this is a test case for true. This also fixes it. I don't really think this fixes everything, but I guess just let's see what it gives us as test cases. Okay, so the test cases are of course correct, but yeah. Oh, this is actually not as bad as I expected. So on the full test cases, we pass over 90 of the 100 test cases. So it's only a few of them where it don't work. One of them is this, where it should be false, but we return true. That's interesting. Let's take this into account. So it should be false, but we return true. Let's think this through. Our program will go and set this as minimum, then this will be minimum, be maximum, then this should be the minimum. Okay, I see we update the minimum and we don't reset the maximum. Yeah, I do think for long cases we need to save multiple candidates. So let's create some candidate pairs as a list, and then we will set the first one to be the first number and none. I hope I can update this. And then this will be none and not -1, because that's bad if that is part of the array. If the current minimum, okay, so we have to iterate through all of the candidates. We no longer have a current minimum and current maximum. So for candidate pair in candidate pairs, and then we will only update the maximum and we add a new one if we find one at the end. Okay, so update the maximum of the current candidate pair. That's if the candidate pair minimum is smaller and the candidate pair maximum is none. Then we will set candidate pair maximum to the current value. I guess if there is a bigger value we can expand the interval, so that will still be useful, but only if this is still bigger than, oh no, it will always be bigger than the minimum if it's bigger than the maximum. I think that's fine. We can also update the minimum, which will be candidate pair 0, and we can expand it to the left. And now we can check for the middle value by checking if it's between 0 and the maximum entry. And now no, the updating of the minimum is not right. The updating of the minimum is only fine if we haven't set the maximum yet, because the maximum needs to be after the minimum in the array. Okay, so only update the min if max hasn't been set yet. So if the current value is smaller than the minimum and candidate pair 1 is still none. Now, do I need to check something else? So basically, a new candidate would be if we haven't used a current value for any of these. If it's smaller than one of the maximums, but then also smaller than one of the candidate pairs. But then it might be in another interval, so current value is smaller than the max. Really, we want to check if it's smaller than the minimum. Then we will set this as current value, and we will not immediately add a new candidate entry, because for a later candidate pair we might still find a 132 value, which is the goal, and then this will never happen. Though I guess we could edit, because then if we have this it still cancels out, but let's just do it like this. So if potential new min is not none, then add potential new min and none to the array. I guess we can do all of these as elifs. We should only continue with this if this is not none. If this is still none, we need to continue with the next one, because then this comparison will not work. So then if this is not none, then we continue with this ridiculous code. Let's see if this is doing anything. Okay, so now the last one works, but this one is no longer returning true. Why not? So this is a potential minimum. Oh, we need to add another minimum. So I guess we only need to check this on conditions where we need the maximum. So basically what's happened now is that we can't add another candidate pair because we never run into this code here if the maximum isn't set yet, but realistically we can have multiple candidate pairs open at the same time. Okay, so here, update the min. Okay, no, update the min if the max hasn't been set yet. We need to do this, not add another. Yep. Oh god. Now, okay, now there's somewhere where here we're checking for the maximum, and we need, this is getting a bit out of hand, isn't it? What have I done now? This is still not okay. If candidate pair is not none, is not none. That's also what we need to do here. I've got a not. Okay, so now all of these are true. This is honestly one of not the finest code I've ever written, but we'll see if it works. Okay, so these were just the 3 test cases, but then if we go submit and we wait a bit, we have passed 100 of the test cases, but then for the last 3 the code takes too long, which honestly I kind of predicted that, so that's unlucky because they just give you a really big input. I'm not sure what exactly I can do about this. Okay, let's consider alternate solutions. We could try all triples, but I'm pretty sure that would be even worse for runtime on long arrays. We might be able to do some breaks. So if we update the value, I don't think we need to consider any of the other. I mean, we can just do does a lot, but we'll see. We also need to reset this for every new iteration. Maybe this was the issue. Let's try this. I'm not super confident we fixed it, but we might have. Okay, so first the 3 test cases are still running. And now let's try the final result. Nope, we're still exceeding the test case. Let's see how long this is. Very long. Okay, so let's see how long this runs for us. How far off are we? 3.1 seconds. 3 seconds and it's exceeding the run limit. That's rough. How long does it run for a small one? Well, basically 0 seconds. Okay. I mean, I have to iterate through the array once. We can't get around that, right? So I guess the candidate pairs are the issue, because we're checking every candidate pair. Let's look at the candidate pairs. So in the first one we have 1, none, then 1, 2, and then we update this to 1, 3 because the interval gets bigger. In this one we have 3, none, we update to 1, none, and then we get 1, 4. Yes. And this one we have -1, none, -1, 3, and then it's true. And for the last example we have 1 with no maximum. We update this to 0 with no maximum. Then we get 0, 1. Then we add -4, none. We get false. And the test is true. I was like, what? How do we get true? But no, that's fine. Okay, so what are we doing here? The only thing where I could imagine that we can shorten the output is if one pair is in another pair, but that should not happen, I think. Let's check. This is slightly shifted from the first, but then these two are the same. Did they really put 2 of the same numbers behind each other? No, they have not. Adds the same number twice. For some reason. That's not good. Okay, so the bug fixing was a bit extensive. I haven't looked at the clock, but I estimate it's around 1 hour later. I wanted to give up multiple times, but as you can see, I did it. I had a lot of time limits exceeded. Yeah, it says an hour ago. But I finally did it. The runtime is still really bad. I think there might be a better way to do it, but I have stopped caring. So what I did, just roughly, was I split the incomplete pairs from the full pairs. So if I only have a minimum, then it goes into this list, and otherwise if I also have a maximum, then they go into the full pair list. And that saves me a lot of checks when adding new numbers. It sort of also logically splits it up. So first I go through the incomplete minimums and see if I can add a maximum to it, and then the pair gets completed. And the thing that needed to be done for one of the last checks was to check if the new interval is bigger than one of the old ones. So basically, if you have 1, 2, and then you get 0 and 4, you can discard the 1, 2, because every new number will be in both of these intervals. And to keep the full pair list from getting too long and increasing the runtime, you want to discard as many pairs as possible. So here I check if the new pair is sort of redundant, and if one of the pairs can be removed. And to clean this code up, I decided to split up my code a bit. So now if I create a new pair, then we do this check and only keep the pairs that are needed. And then here we just update the minimum, and then we go through all of the pairs. And again, if we increase the maximum with a new value, then we again check if we can discard some values. And then, as before, we can check for the middle value as well, and check if we might add a new minimum. And that will be added to the incomplete minimum list now, and not as like a full pair. So yeah, it was a lot of fiddling. And like I said, there's probably a better way to do this. But if you take a look at the clock, I'm not gonna find it. I'm proud for sticking through it. I hope it wasn't too confusing. I think I'm allowed to add the code, so I will try and remember to put it on my GitHub. And that's it for today. Thank you so much for watching, and see you in the next one. Bye!